else will be jumping on here as well. We'll just get going here. Welcome everyone. Mike Gray from Hurley Engineering. We're glad you could join us with our webinar today. We're going to be talking about CosmoGas, a new line for us here at Hurley. We've got Daryl McLaughlin from Sales, Service, and Technical Information for Alaska, Washington, and Oregon, and now Idaho, I guess. You include that as well. So he's got a lot of information, a lot of detailed information. We'll try to keep him under wraps so he doesn't get too lost in the weeds. But we can get there if you need it. So please use the chat box in the Q&A, and I'll be watching that, and we'll try to answer your questions as we go. Otherwise, we can do a stop or a pause, and when we do that, we'll try to address those as well. So with that, I'll turn the time over to Daryl, and we'll get rolling with this webinar. Thanks again, everybody.
All right, thank you, Mike. Yeah, appreciate everybody showing up. I know everybody's busy, so I really appreciate you guys giving us some of your time so we can go over CosmoGas today. Like Mike said, CosmoGas is new to Hurley and somewhat new to the North American market. They've been around in Europe for a long time, over 60, 70 years now. In fact, it's still a family-owned company. They're an Italian-based company, and we're glad to have them here. We think they're really going to fit a hole in some of the markets that we see and be a good solution for a lot of projects that we have. So I'm going to move forward because we have a lot to cover, and I want to make sure we can get through it. We have three basic products that CosmoGas has brought to the North American market, being a boiler, a water heater, and their Tudor bit, which is their cascade or control system. We're going to focus primarily today on the water heater, the instantaneous water heater, because we think that'll be the most benefit to what we're seeing in our markets. The backbone of their equipment is their heat exchanger. So a lot of people are familiar with the water tube heat exchangers we see these days, right? And they're made by third parties. They're Giannoni or Sermeta or places like that. The heat exchanger that CosmoGas uses is actually patented by them, sourced and made by them in their factories in Italy. So this is not third party, something they're putting in different lines. This is something they've made, designed, and patented for themselves. It's still a water tube design. It's a radial variable circulation. So they've got a different shape than what you would typically see. It's not quite as oblong. It doesn't tend to foul as much. It doesn't have flow issues. It keeps the turbulence where they want to keep the turbulence. And it's constructed of 316 titanium stabilized stainless. So really good corrosion resistance properties and excellent against thermal stresses as well. Another thing they've done is they've ensured that there's no weld joints anywhere in the wetted surfaces. So just every weld joint you have is another potential for failure, another potential for problems, and that's been eliminated by having a complete seamless heat exchanger. So you can see here, here's the two main, that's the boiler in the black and the water heater in the red. Primarily, this is a modular design. So what that means is they offer a heat exchanger in each one, but we can stack up to 4 heat exchangers. So if we started at a 250,000 BTU boiler, that would be a single heat exchanger. We can go up to 4 heat exchangers, and now we have a 1,000,000 BTU boiler. By the same token, we've got 5-to-1 turn down on each one of our heat exchangers, which includes the burner. So if we go from 250,000 BTUs with 1 and a 5-to-1 turn down, by the time we get the 4th heat exchanger and get up to 1,000,000 BTUs, now we're talking about a 20-to-1 turn down. The benefit to doing it this way is when we do a 20-to-1 turn down with 4 separate heat exchangers, we're not having to try and accomplish that high turn down with a single burner. Because often when we do that with a single burner, we increase our excess air and we lower our dew point and we don't condense as easily and we lose some efficiency there. So by doing it in 4 separate burners, we don't have to increase the excess air and we can maintain efficiencies all the way through that turn down range. So that's on all models. So either the boilers and the water heaters both are available with from 250 all the way up to 1,000,000. Now you'll see here on the water heater, there's 2 additional models. We've got a 199, a 250, a 399, 500, and so on up to 1,000,000. There's 6 models because there's actually 2 different heat exchangers. And by that, I mean, we've got a 250,000 BTU heat exchanger. So that if we went from 1 to 2, we go to 500. A third heat exchanger gives us 750, and a 4th one would give us 1,000,000. Some jurisdictions have, and CSD1 requirements, like to see BTU values under 400 or a 399 and under 200 or a 199. So for that reason, CosmoGas made a separate heat exchanger that's a 199 version, and we can stack two of those and have a 399. It's not just a derated or it's not the exact same heat exchanger, just derated to be sold for this particular purpose. It is physically different in characteristics. So the 250,000 BTU heat exchanger would have 15 wraps of the water tube inside the heat exchanger, while the 199 and 399 would only have 13 wraps. There's actually less surface area for the BTUs. So, and then you can see some of the other items here. It's up to 43 gallons per minute total max at a of hot water output at a 45-degree Fahrenheit rise. So that can vary quite a bit. But if a million BTUs, 20 to 40 gallons per minute is very acceptable depending on your delta T. So one thing that was super important to CosmoGas is serviceability, right? So everything they have is accessible from the front. You can see here in the picture on the left, we've got up to our 4 burners all stacked in once. If a heat exchanger has to be replaced, there's 2 mounting bolts and it pulls right out. All of our burner safeguards, our flame controls here, are on the right-hand side as well. And if you need to service those, you can see on the next picture how that door swings open and you have access to all the wiring connections and controls. Our main interface is right on the front too, and that swings open so you can access it. There's nothing that you need to service on this equipment that you can't get to from the front. So then again, if you look over here, they also provide filters that come with every unit. That's a standard item. So whether you're doing outside air or you're just using room air for your intake air, it's going to be filtered, and we're going to use this cabinet like a plenum to deliver air to each one of our burners. And we want to deliver this cleanest air as possible. It helps protect the heat exchanger, protect your burner, protect your fan motor, or your blower wheel, all those things. So
Daryl, is that a cleanable filter?
it is a cleanable filter. So it's a directional filter, right? So, and there's a picture here in a second, but you can actually spin that filter 180 degrees and use both sides of it,
Uh,
but you can't flip it. So if you flip it, then the direction will be wrong. But in the meantime, you can clean it too. There are provisions in the manual that comes with it that this filter is cleanable.
Thanks.
And so you can see here from the top, this is our intake air, and you can see that filter. And so what I mean by having two uses without cleaning is the filter extends all the way to this lower portion here. So if I were to pull it out and spin it 180, I'd be using the other half of the filter. Now, if I flipped it over, then it would be going the wrong direction. So you can't do that and get the different uses, but spinning it around 180 degrees and using it twice is perfectly acceptable. So you'll see our exhaust connections are here on the top as well. And then all of our electrical connections are on top. So most of your connections will be made at the top of your venting and your electrical. So one other item that they've included is the neutralizing canister. So if in most instances, this has always been a problem. When you put a condensing boiler in, now you might have to raise the housekeeping pad. You might have to do any number of things just so that you can have free flow or gravity drainage of that condensate to a floor drain, to a neutralizer. Well, CosmoGas includes their neutralizing canister in the boiler. So it's already elevated to the point it needs to be. You don't have to elevate the pad any further. You can set this on any surface that you need. You need to keep it level. But then all you need is a small amount of elevation change so that you can drain from that neutralizing canister to your floor drain or to your pump or whatever you're going to. So it's a nice feature to have that already included so that you don't have to put as much into the installation and maybe change concrete and pads and things of that nature. And you'll also notice that down here it comes with, this is the back of the boiler, it comes with the neutralizing media supply with everyone. You don't have to order that separately. So another thing they do, and I'm going to take the time to talk about this real quick, because they load for their service is such a key aspect of what they're trying to provide and make them easily serviceable. They've got this parts kit. So if you ever need to service it, the parts kit is really what they would prefer you to have. If you buy this one parts kit, it's got every part that you could need for about 95% of the issues. So when I say that, that means every gasket you need, igniters, flame rods, gas valves, fuses, anything down to a new burner control, a blower motor, All those things are already included. Essentially, the only things you wouldn't get in the service kit are refractory pieces because they're too easily damaged in shipping and they're fragile. If you put them in somebody's service truck and they ride around and bounce around, then they're going to be broken the time before you need them. So, and then the heat exchangers as well. Those are just a big item that can't be put nice easily into a box. So, but the service kit comes with all the parts that you would need otherwise. And as you use them, there's barcodes and part numbers right underneath each part. So you can pull that barcode, send that number in, and we can get you whatever parts to replace what you use. The other thing, let me go, let's see here. Bear with me 1 second. I'm going to um, go back to the right here. So one thing I wanted to mention too, not just the parts kit, but the other, as far as being the serviceability of this boiler. When it comes in order to keep the pressure drop low, this is not just one pass of tubes. Immediately upon entering the heat exchanger, the water is diverted, and there's actually 3 different runs of tubes in one pass. So what that means is when you go to clean it, you need to, if you want to do a water side cleaning of the heat exchanger, we would need to be able to divert flow to each of these 3 paths. Well, CosmoGas has a manifold. It's a quick threaded hookup that you can put to the inlet of these boilers. And when you want to do a water side cleaning, you turn it on and it'll divert the flow to all 3 paths equally. So it won't be a concern. It's a very effective way to clean the water sides. By the same token, when they're doing fireside cleaning, it's another issue we run that there's not a lot of great tools to do this effectively. And CosmoGas has got a tool that hooks up to the front and you use your drill and it'll brush out the fireside and clean any debris out of that can be then flushed out. So I just wanted to show that heat exchanger real quick. Okay, clearances. So common clearances, it's only 4 inches clearance to combustibles on the sides. When you see larger clearances for the top, bottom, and rear, those are service clearances. So those are for ease of access, not for combustibles. Your combustible clearance is only 4 inches. And that holds true whether it's the large version. So this would be our large, either 750 or 1,000,000 BTU model, and it's the taller of the two. And if we go to the smaller one, that would be either 250 or 500. It has the same clearances, so nothing changes there. 4 inches to combustibles, 20 or 40 inches clearance for service and access, with no change between the models. So here, just a little bit quick rundown of the nomenclature. It's pretty straightforward. It tells you what size, if you look at the nameplate, it'll tell you what size boiler you have. But one thing to really note, they're all going to be floor standing. If you have a boiler, you're going to get an H stamp. And if you have a water heater, you're going to get HLW stamp. So the heat exchangers are not interchangeable. They're actually ASME stamped differently depending on if it's a heating or a hot water application. Just some keep in mind in case you have both at your location, you've got to keep those straight. So also there is a motorized valve option that we'll talk about and I'll show you here in a little bit. So you can get them with or without motorized isolation valves on each of the heat exchangers. This is the common kit that comes with all of the water heaters. So whenever you order one, these are not things you have to order separately. They just are automatically sent. You get the adjustable feet, the neutralizing limestone or neutralizing media. We'll get a tank sensor or system sensor that can be used for temperature control. And you'll also get the orifice for propane conversion so that if you ever need to switch to propane, you don't have to order a kit or do anything separate. You can just place this orifice in, remove the gas orifice, and then tune it to the propane standards. Now, this is a picture of a side view of all 4 boilers and what the possibilities are. But mainly I want to show you, here's the motorized valves. You can follow my cursor. You can see they'll put them on each one. So a single heat exchanger unit, obviously you don't need one because there's only one heat exchanger. But the rest of them, we can put motorized valves. And what this does is prevent flow through heat exchangers when they're not in use. So if you wonder, that's an upgrade in efficiency. You can size your pumps differently, but you do need to have variable speed pumps. So if we start closing off one heat exchanger, we're going to have to account for that in our flow and head loss for our pump. And a variable speed pump can handle this pretty effectively. Right now, most of the units that they're moving in North America are without these valves, and people are using variable speed pumps anyway. But it's just one less complication, and most people want to try and avoid them. So, but that's always an option if you're trying to get premium efficiency, premium flow rates. The motorized valves are there. Okay, the back of the heater. So, just to familiarize with what comes standard on every installation, I'll start from the top here. So 35 are just auto vents for easy bleeding of air, so you can purge them and charge them with fluid for the first time. Then we've got our header sensor that's pre-built in. You don't have to order that separately. That's already there. And then the water outlet connection, threaded connection, and inlet connection, again threaded, as well as drain connections down here on the bottom. So if you ever have to drain things down, that's where you would go. Each of these units also has a temperature and pressure gauge on each loop. So each heat exchanger will have its own temperature and pressure gauge, as well as they'll have their own TNP relief valve. And that's this item 41 here. So it is a TNP. And for those of you that require pressure only reliefs, then that would have to be done separately. A TNP is what comes standard on them. And that's for the water heater version. I'm sorry, the boiler version would have a relief, pressure only relief. Moving on, this is the internals or the heat exchanger and burner combination. So you can see our gas, this is our gas valve here, and this is our Venturi or pre-mixing device. This is a pre-mix burner. So over here would be our motorized valve if we have that option included. Right above it here, number 16 is a flow sensor. So each one of these heat exchangers, they're low mass. We want to protect them, make sure they have flow all the time. They do have flow sensors. On top, we've got a pressure sensor. So we also want to make sure they have adequate amount of pressure. We're trying to guarantee that there's no air bubbles, there's no pockets. We're flooded and flowing at all times. And to do that, we have a pressure sensor. Now, if we have multiple boilers or multiple heat exchangers, excuse me, we'll only have one of these pressure switches. So we'll have one on our primary heat exchanger, and the rest of our heat exchangers will just have a plug. So, and then standard stuff that's common to everything else, high limit. So high limit down here at the bottom on the outlet, and then you can see igniters here, flame rods, and then the ignition transformer here as well. So now, because we're putting 4 heat exchangers in one cabinet, or up to 4 heat exchangers, these boilers are already essentially common vented. So if we have 2 heat exchangers and we didn't have what they're calling this flapper valve here in the display or the depiction, then we would potentially flow flue gas back down through our other burners and then out the intake and into our cabinets. So all of the burners come with these 3 components: the flapper valve, the flapper magnet, and the flapper sensor. And that's strictly to prove that that gate is closed and we can't recirculate exhaust gas back into our cabinet. It also checks that they're open when they're supposed to be open and closed when they're supposed to be closed. And it's absolutely necessary whenever you common vent any burners. So, and again, inside our cabinet, all 4 of our burners, or up to 4 burners, are common vented. Any questions, Mike? Or
I don't see any, Daryl.
okay.
Everybody out there listening, maybe if you have some questions about, with other models of other manufacturers, you may see some differences of. It's a good time to maybe get some clarification. So pop that into the chat or Q&A if you have any questions that way. Thanks, Daryl.
Okay. Thanks, Mike.
Yep.
So just a few more items here quickly to show you. We've already looked at some of this. Exhaust connections, this control board up top, that would be our remote input. So if we're going to control these boilers remotely, that would be our control that enables that. Our block vent pressure switch coming here is mounted right here, easily accessible from the front. And then all of our condensate drainage would be down here. In fact, there's a drain switch. I think we've got another slide that'll show that. So, and here we go. So this is, yeah, the drain switch. So if we start to have our condensate drain back up, it needs to be cleaned, or for whatever reason, this switch would stop it from backing up into the heat exchanger and causing excessive corrosion or problems with the burner ignition. So that's where that's located right there. And then we've also got a fuse to protect the heat exchanger from failing catastrophically. So we'll cover that here just a little bit as well. So this is our stand.
Daryl, a quick question on there's 4 sizes, but then we have 6 different models. How do they
Right.
accomplish that, the deration to a 199 or a 399?
So they don't technically derate it. It's an entirely different heat exchanger.
Oh,
So
okay.
So there's 2 heat exchangers. There's one heat exchanger that has a base value of 250,000 BTUs output or input. And that heat exchanger has 15 wraps of the coil in the tube to be able to accommodate that much heat. Then there's a second heat exchanger that's a 199 output heat exchanger or input heat exchanger, and it only has 13 wraps of the coil for the heat exchanger. So they can take that 250 base model and they can stack it up to 4 times, and that gives us those 4 options: the 250, the 500, the 600, and the 750 and the 1 million. Or they can take the second heat exchanger, the 199, and stack it twice and go 199, 399 to account for those 2 models that fit certain codes and CSD requirements. So between those 2 separate and completely different heat exchangers, they can build 6 different models.
Thanks for that clarification.
Mm-hmm. So this is our standard relay board, and not too much here other than to note that we do have the fuses, all of our pump outputs if you need them for heating pumps, domestic water pumps, local pumps, if you're doing primary, secondary, that sort of thing. They're controlled through these relays. They're all rated at 3 amps. If you're going to pull more than 3 amps, then we'd have to have isolation relays. And I've even got a small schematic later on that'll show you how that isolation relay could be installed. So, and then one more fuse just built into our flame safeguard, and that's right here, and that's commonly overlooked. But on the low voltage side, if you ever have wiring issues or shorts or grounds or things like that, this is the fuse that generally pops, and you always want to check on that one. And that's going to be built in our control boards, mounted right on the front of the burner, or front of the boiler. Last, before we start getting into some more of the technical sizing things, just a common thing that's been seen is lifting and installation. So when you go to lift these, they've asked that you keep at least a 3-foot minimum between the lifting lugs and your lift point. That's just to keep the forces pulling upwards on the unit, because they can handle that well. But if you get that too small, that dimension is too tight, then it tends to pull the lifting lugs inward, and it can warp and distort the frame of the equipment. So, okay, so let's talk about the most important thing with these. And probably a lot of people have experienced this, but when you're doing instantaneous hot water, and keep in mind, we can pair CosmoGas with tanks as well. But when you're doing instantaneous hot water, flow is absolutely critical. If you're not getting enough flow, it's time, temperature, and turbulence, right? And if we can get those three things correct, then we're going to have a much greater success rate with not fouling, not scaling up, and not damaging a low mass heat exchanger, right? So flow is critical. We're going to give a couple of examples of what they do and what they're trying to accomplish with flow here. And the first one is in industrial applications. So what CosmoGas means by industrial applications is we do not have an anti-scald or mixing valve, which would normally be right here, right? So everybody's probably familiar with that. If we're approaching anything over 120, if we're going to put 140 degrees out, we need a 3-way valve, a mixing valve, anti-scald valve, something along those lines to prevent from people burning themselves downstream. Well, if ever you have an application that doesn't require that 3-way valve, it's considered industrial, and this is the piping schematic that you should use. In fact, I'll go to the next slide here. You can see they've got 2 distinct flow circuits that they're concerned about. So the first flow circuit is going to be F1, and this is the critical one. This pump down here has got to maintain the flow that we want to be able not only to put out the hot water we need, but to prevent the scaling and lime scale buildup on the heat exchanger. The flow circuit 2 is just going to be the load of your circuit itself and what the hot water demand is in that building, right? So keep in mind, again, this is just for industrial applications. Now, if I go to the next one, this is going to be a more typical, probably 80, 90, maybe even more % of your instantaneous water applications. And here, all we've done is we've added that 3-way mixing valve or that anti-scald valve, right? So when I go here and look at the flow circuits now I've got a third flow circuit because of that. I've still got my F1 circuit that I've got to keep the flow where I need it to be to prevent limescale buildup. I've still got circuit 2 that is going to be indicative of what my actual domestic hot water flow is in that system. But then I've also got the third flow circuit, which is just my recirculation. And that's critical as well, because here we're suggesting 9 GPM, and that's what generally you need to keep enough flow through this 3-way valve so that it can accurately mix the water and keep the temperature correct. I will say that's a rule of thumb. You should always look, this 3-way valve is not sold with the CosmoGas. That would be sold separately and independently. So look at what equipment you have on site. Look at your manufacturer's recommendations. They might need more or less, but I wouldn't go below 9 GPM. But if they require more flow to accurately mix the water, then you can certainly do that as well. And so our third idea here, or system here, is a storage tank. So this can be done as well. And it looks more intimidating than it is, but we've still got the same three flow circuits. Between the tank, we're keeping that one circuit so we keep flow in the boiler. Our circuit number 2 is what's our domestic water load is going to the facility. And our circuit 3 is our recirculation coming back to the anti-scald or three-way mixing valve. So now that we know what our circuits are and what we're trying to do, we're trying to keep the flow just where we want it, right? So um, one of the most important things you can do is know what the quality of your water is. For a lot of people, that's just as simple as calling your local municipality and asking them, hey, can you give me a report on this? They have to monitor these items anyway. They can tell you pretty quickly. You know, if you're out in a remote site or a rural site, maybe they're on well water, things like that. Now it might be in your best interest to take a sample, get it processed, and find out what their actual values are. But we want to see things like water hardness, um, pH, sulfate, total dissolved solids, all of these things combined. If we can get under the right levels, we've got a much better chance of having success with regards to low scale buildup and low corrosion. So these are CosmoGas's recommendations of where your water quality needs to be to have the most success with their boilers.
Daryl, so if you run well water or something to that effect, because we have a lot of that here in Idaho, they'd have to have some kind of filtration ahead of that before it goes into the water heater itself.
You can. So it just depends. You know, every well is a little different, and water hardness is definitely an issue. Total dissolved solids and grains per gallon. So if softeners, just to remove that, but occasionally it's not just a hardness issue. Now that is most common with well water, but sometimes if it's a chloride issue, that's not something that's necessarily taken care of by softeners. Now you might need um, a different kind of approach, right? So it depends on what you're doing. The softeners are the most common thing for solids and water hardness, but pH and other items might need a different approach. So you just have to be flexible in that regard.
Thanks.
Okay, so moving on here, we're going to get into some of how we size these. I'm going to try not to be too detailed, but I'm going to try and hit the high points for how we size these pumps and keep the flow accurate so that we don't scale up the equipment. This chart is in all of the manuals that come with CosmoGas equipment. And you can see starting out over here, they've got a water hardness. So my first number here is going to be my parts per million of water hardness. And the second number is grains per gallon, depending on what number you typically get with your reports. So the second line is going to be maximum water temperature at that hardness. And then the third line is going to be the recommended flow that you should have for that boiler at that hardness and temperature level. So you can see, and we're going to pick one out here and do an example here in just a minute here, but if I were to say I have 100 grains or 6 grains of water hardness and I'm running at 140, then on the 750, I should have at least 45 gallons of flow through my boiler. And when I say that, let me step back for 1 second here. That applies to this F1 circuit only. So that 45 gallon minimum is going to be for F1. Let me go back here. So, and that will change. If I'm doing 1,000,000 BTUs, then I would be 60 gallons per minute. Or if my hardness changed, I would just have to find the corresponding spot on this graph and then select my minimum flow rate for that F1 flow circuit. Now, once I've done that, I can go over here to my pressure drop chart, again provided in the manuals, and I can take that across and I can follow my flow up and find what the head loss is of the heat exchanger at that flow rate. So again, that would be my minimum. I could take that head loss and then I could take that to my pump curves and I could size it accordingly and find out what pump I need in order to accomplish that task. So there's a little bit more to it. So that gives you a baseline of where you would start, but we have to account for other items as well. So we'll do an example. We'll start here from what information you're likely to have on site and what you would do with that. So let's say we go on site and they know their demand is 18 gallons per minute. Maybe you've done a fixture count and you know, or it's just one item, or it's some kind of washing or laundry equipment. But you know you have 18 gallons of demand at 140 degrees. You also know that you're getting 50 degrees in of cold water, of makeup water, and your hardness is generally 125 ppm, right? So we can determine that we're going to do 950,000 BTU boiler. That's actually a million at 95%, so our output's 950. Then we're going to run through the math to make sure that that boiler can accommodate this load. So if I were to use my standard BTUs equals 500 times delta T times GPM, we can see that that million BTU boiler would do 21.3 gallons per minute at 140 degrees. We only have an 18 gallon per minute need, so we know a million BTU boiler would be adequate. If we step down to 750, we would come in under the 18 and we wouldn't be able to accomplish that. Or it would be close enough to be concerned. Okay, so now I know that I'm going to need, if a million BTU boilers, if I'm using a million BTU boiler, I'm going to go back to my chart. Million BTU boiler, 125 parts per million on my hardness. So my minimum flow rate would be 68 GPM. If I were to take that to here, now my 68 GPM, follow it up, I've got approximately 33, 34 feet of head loss at that flow rate. Now keep in mind, that's a minimum. So if you get a pump that does just 68, we're always going to size it a little bit over because we don't want to be sized for the bare minimum. Okay, so then the next thing, now that we know our minimum rates, we've got to consider a few other things as well. And again, here's our flow. So that's our 68 gallons per minute on our flow one or F1 flow circuit. But now we've got to worry about two things. We've got to worry about noise, and we've got to worry about potentially erosion. So if we get too fast, velocity erosion could be a problem. It's not going to generally affect our heat exchanger. The heat exchanger is made out of materials that are pretty stout, pretty sturdy. We're not concerned with erosion there. But the near boiler piping, the copper there on that F1 circuit, we definitely don't want to cause erosion problems there through the fittings. And we don't want to have too much noise either. So generally speaking, we're going to try and keep our flow rates and our flow velocities at under 5 feet per second. So without going through how they got down to this, you can see standard formula here is the flow area and velocity. And we're going to use that to calculate the pipe area that would be necessary in order to stay under 5 feet per second. And in this instance, using the 68 gallons per minute from the earlier example, we have a 4.36 square inches of pipe area. So which comes into a diameter of 2.35. So this is a 2.5 inch pipe, right? That means if we want to keep our flow velocities under 5 feet per second, we'd have to size our near boiler piping, this circuit right here, with all 2.5 inch pipe and fittings. Am I going too fast? Does anybody have questions with that?
I don't see any, Daryl. You must be explaining it really well. Pretty straightforward. Yeah.
So now once we've done that, we've got the pipe size correctly. Now we're going to do a pressure drop because now we need to see what kind of head loss does this add to our heat exchanger. We'll count up all of our fittings from the pump, the loss through the pump, the elbows, the T's, the check valves, unions, and you can get charts online that usually, or you might already have the charts that will tell you what the equivalent feet of pipe is for the head loss associated with that. So what we've done here is gone through and seen, okay, we've got 5 feet of pipe here. This union has 3 feet of equivalent pressure drop. This T has 30 feet of equivalent pressure drop. Then we have another 3 feet of pipe, so on and so forth. And we've just taken all the equivalent feet of pressure drop through all of them. We found out we have a total of 29.5 feet, equivalent feet of 2.5 inch pipe. So if we were to do the math on that using readily available charts, we come out to 1.416 feet of head loss. So where we started off at like 33 feet, 33.5 feet of head loss to our heat exchanger, now our total system head loss is up to 35.5 almost feet of head loss. So when this comes into play is when you're sizing pumps and you're right on the line and you're curious, then you need to take into account what's my head loss through this piping at the required velocity that I need. Otherwise, you could potentially undersize your pump. Now, in reality, it's only about a 5% difference, and that's pretty consistent across the board. So you can just account for that at 5%, and as long as you're not within that range, move forward. But if you start getting close, then you need to rethink and make sure that run the calculations, make sure that you're sizing the pump correctly. Because again, low flow in that F1 zone is going to be your enemy in this boiler. And then just a curve, and I think we've all seen curves, but 68 and 35, and we just followed across, and then we pick the corresponding pump to match what we need. So, and this happens to be a Grundfos model. So that's the long and short of sizing pumps. That's the number one thing we've got to do with this equipment. Mike, can you think of anything that you would like to add to this?
Yeah, it's just whenever, I mean, it's pretty critical with pumps and flows, especially when you're applying a lot of heat to a small amount of water in that heat exchanger. You can always precipitate out those minerals and stuff that are hardness that are in the water. So getting that correct is going to make that piece of equipment not be a 3 to 5 year piece of equipment. It's going to last, 15 to 20 years if you're keeping that flow where it should be. So that's
Yep.
pretty critical point. Some manufacturers don't dive into that very much. I would double check everything depending on a manufacturer to make sure that those flow rates are within those parameters. And CosmoGas has a big heat exchanger, a big opening. So even if that is critical to have flow, you can imagine if it's a smaller tube diameter, smaller tubes, where they can
Right.
run into issues with the hardness.
Well, and one of the unusual things too is those scale forming salts that would precipitate out. It's most things are more soluble the hotter you get, but most of the ones that we have problems with, the calciums and things, are not. So they'll precipitate easier the hotter we get. And if you don't have other ways like flow and turbulence to take care of that, then you're going to be in trouble. So uh,
Yeah.
it's the number one downfall of instantaneous low mass water heaters, right? So it's got to be addressed. And if you do a little bit of lead work on the front end, then your success with these boilers will be amazing. I've seen a boiler that was running for I think almost 2 years or a little more at and we just the water side and the fire side was not dirty at all. It looked almost brand new. So it just shows what's possible if it's sized and designed and installed appropriately. So
Yeah, reach out to us at Hurley if you have any questions on pumps, because we're pump
right,
guys, so we can help with that.
absolutely. We can. So if you let us know, and we'll get into that here in just a second, but we'll size a pump for you. We can provide a pump as a package, and we can make sure that it has the flow that you'll need to be successful. So.
Yeah.
We brought it up earlier. I just want to show here if you go over that 3 amp when you're putting in your pumps, this would be how you would attach an isolation relay so that you're not running more than 3 amps through the local relays and fuses. So you'll notice this is those terminals on top of the boiler, and the left hand side is our high voltage or 120-volt terminals, and the right side is our low voltage or 24-volt terminals. And that would be our sensors would be tied in there. The jumper is field supply. This would be possibly stops or just anything you would need to disable that and shut it down. You could remove the jumper and tie into those terminals instead. Another unique feature that they have when you're trying to control this remotely is you can send a 0 to 10 signal to manage set point. So you can see here, let me follow along here. If I go to the max here, parameter 3017 in the control, that's where I would set my temperature at 10 volts DC power, right? Or signal. My minimum temperature, I would set in parameter 3018, and that's going to be at 1 volt. So if I'm setting remote temperatures to this and trying to change my output from 140 to 120 or 110, maybe sometimes you're running for just a laboratory, and maybe sometimes you're going to feed something to a kitchen or for whatever need that you might need to change temperatures, you can do it through a remote signal. Now, a lot of boilers are required to have two different signals. They'll need a modulation or a signal to change the set point, an analog signal for that. And they'll also need a binary signal, an on and off, just to tell it to turn on and off. CosmoGas does all that with one signal. So the 0 to 10 signal operates between 1 and 10 for set point. But if I drop that signal below 1, that's the signal to tell the boiler to just turn off. By the same token, we can't tell it to turn back on at 1 because then if we're sitting real close to that, we might bounce back and forth and we might have some short cycling of the equipment. So the boiler won't turn back on until that signal is increased to 1.5 volts. But our minimum temperature is still determined. So you would increase the signal to 1.5, then you could drop it back to 1 volt to reach your minimum set point, if that's what you desired. Venting options. So again, these are already commonly vented with multiple heat exchangers inside the cabinet. We can do sidewall venting. We can do vertical terminations. We can even do sidewall intake and vertical exhaust. What we would like to avoid is having opposite sides of the room. So having our intake on the east wall and our exhaust on a west wall. Pressure differences, winds, alcoves, all those things could cause problems with these burners and with any low NOx premix burners. So if you just follow the different or the drawings and selections they have already shown in the manual, you should be fine. But that's the main thing. Make sure you keep if you can keep them on the same wall, it's always better, or vertical with your exhaust only. Same thing, if you're going to go with coaxial venting, concentric venting, then you can do sidewall venting, you can do vertical venting, you can do exhaust only too, but it is important. Make sure you keep your free air intakes. Do two of them, keep one high and one low. I think that's written in the CSD ones now. I'd have to look, but depending on the installation, that does become critical at times. So, as far as vent materials go, PVC, CPVC, polypro, stainless steel. If you're not sure if what you have matches, here are the applicable USA codes in the US that dictate what is good for this application. So stainless steel, if you need AL294C, there are different versions of AL294C. As long as they meet UL 1738, CosmoGas is happy that they'll be fine for their equipment. Same thing with pipe and fittings, UL 1738, or the other ANSI ASTM codes. They even give one for the pipe, cement, and primer you should use that it meets certain ANSI and ASTM codes as well. So one thing I want to note here, let me get to the next page. Yes, so the exhaust and intake here, these fittings on top are meant to accept different sizes because you're going to have different diameters of PVC, CPVC. They're not meant to seal from moisture. So when you install these, if you don't put the RTV in here, you have not sealed for moisture and you will leak condensate into the room. You have to use the RTV sealant to get that watertight seal. Even with the stainless steel, the AL294C or Polypro, if you stub them in here, that venting manufacturer needs to provide a way to seal that off. So sometimes stainless steel appliance adapters will have a gasket built into them, but if they don't and they're just a stub, then you still need to use RTV on that as well. And the same thing with Polypro. If there's not some sort of gasket or method to stop the water, then the contractor needs to make sure that there's some kind of sealant there to prevent water from leaking out. Next here we've got, so you can see this is the location of our gas orifice. Comes standard on every boiler, but we do get the propane orifice as well. So if you ever have to pull that out, put propane in, this is where it goes. You can see where it's going into the suction side of the blower. And then you'd have to adjust the regulators accordingly. So if I switch to propane, my O2 numbers are going to be a little different than if I was running natural gas. I believe we've got, yeah, here's our chart. So you can see less than 250 parts per million carbon monoxide at propane, less than 150 for natural gas. And then our O2 numbers are going to run 5 to 4, high 4s, low 5, depending if you're low or high fire. And they vary a little bit more for propane, but they've got them for each different fuel and for each different model. So just make sure you reference this when you're doing your startup. You can also note in here, they've got a model number on the orifice. So if you're not sure which one you have installed and you want to verify, all your propane orifice should be stamped with the number 700, and all your natural gas orifices should be stamped with the 930. Now, lockout codes. So pretty standard lockout codes. This isn't to show you all the different lockout codes they have, but just to show you that in their manuals, you're going to have a whole section just for alarms and errors and things of that sort. So first thing you'll see is the code itself, and second will be the description of what that code entails. The third column is going to be the different items you can check that could potentially be have gone wrong or failed that might be causing this issue. So once you've determined which one of these things that you've checked has caused a problem, you can go over to the final column, and then they've got the solution and things you should try in order to correct that. And it might be that you have to replace this. It might be reset. It might be several things, but at least basic troubleshooting is included in the manual. We've also got these errors before, and this is the one I wanted to bring up from earlier. So error 72. So the difference is, if I go back here, LOC is going to be a lockout. That's something I'm going to physically have to reset most of the time, right? So, or all of the time. Error codes will generally correct themselves once the condition has changed. So what I mean by that is if we look at, let's say, the second one here, error 65, supply voltage polarity. If we've got the polarity wrong, as soon as we change that polarity, the error 65 will go away. We shouldn't have to reset it. It'll do it automatically. By the same token, we've got this error 72, and if you remember, that's the fuse in the front of the boiler. So where, let's say you had a runaway boiler or it's been scaled up severely and it's not able to remove the heat from the heat exchanger on the water side. If you get hot enough to pop that fuse, then you'll get this error 72. So just keep that in mind. If you can't reset that, then that's likely because that fuse has been blown. So, and here, that's the location of the fuse on the front of the boiler, just for reference here in the bottom right corner there. Okay, another feature they've got, so commonly people run into, let's say for whatever reason, you've lost a master control, because it's a master-slave relationship for all of your controllers on this, right? And one is going to act as the master to control the other three as slaves. Well, what if you're doing maintenance or you're pulling this one out or the master has been fried? Well, you've got quick Molex style connectors that you can unplug and replug in, and now you can move that master control. And now you've got a new master operational. Whenever you do that, there are certain things that you have to change. So you can see here, if I'm running 2 heat exchangers, here's where my dip switch on the controller, and you can see over here that the dip switch is location and what position it indicates. So down is on, up is off. So if I had 2 heat exchangers, my master would need to be, go to parameter 3001, set to 2, go to 2003, set to 0, and make sure my dip switch is off. Same thing on this bottom board, my dip switch should be down. Here's what my parameters are set to. But basically for any configuration here, I can, if I have to unplug and replug and change one of these boards, they tell you exactly what you need in order for that thing to communicate and operate correctly. Now looking on the inside, one of the most important things during service to keep track of are these front refractory plates here. So over time, if they've had condensate back up for some reason, or they've been dropped or pulled out abruptly, you will get cracks in this. And if it gets too big of a crack, that heat and temperature and flue gas will get through that crack and hit the aluminum backplate. And then that'll overheat and warp and it won't seal correctly. So it's important, it's vital that whenever you're doing annual maintenance, you're going to be looking at the firesides anyway. Let's pull these out and make sure there's no cracks, make sure they're in good shape, and replace them if necessary. So now this is the front refractory by the mesh burner. But when we pull it out, we've also got a rear target wall also that will bolt to the back of the heat exchanger. And that one should be inspected and replaced as needed as well. So at least once a year. And then, you know, once a year is a good thing for heating systems. But when we're doing potable water, it's more about usage. So if you have a time of year that's a really heavy demand, maybe check it twice a year. So every system's a little different, and do that accordingly. But if you have heavy usage and you're running year round, then maybe you need to do it once more than once a year, just to be comfortable. Here's just some examples of what you can see. So you can see the photo on the left. Even though this is not brand new, it's definitely in good shape. So you can see this kind of discoloration. This is normal operation. This is what happens when you're operating in a condensing environment and you have that moisture all the time. But it doesn't look bad. Now, when I get to these, you start to see the darker colors. You can see how the water seems like it might have pooled up onto the bottoms of the refractory, and it's just generally darker all around. That's not good. And the other thing too, if you see in here, there's a crack in that refractory on this far right one. This is a bad example too. Not only that, but your metal, your retaining washer that holds that refractory on has gone super dark. All these things are indication that you're not in good working order. So, and if I go down to the burners, same thing. this thing is going to be in the presence of flame all the time. We don't expect it to look brand new, but we don't want it to look burnt or crispy or crack, have cracks in the refractory, like right here by this flame rod, if you can see that. So just some good ideas where we can be like this. We just don't want to be here. So on the fire side, this is more typical, like I said, for condensing applications. But if you happen to be running hot all the time, this is what you'll see. It doesn't mean most of it's still shiny. This is just stuff that has dropped out that needs to be cleaned. So as long as you can get this cleaned out and clean it, and again, we have the fireside cleaning tools to do that, you'll be fine. However, the minute that metal starts getting dark, let me go here. There, here you can see it. So if you don't clean it off enough and your metal gets dark like this, as opposed to shiny, this is when you've damaged the heat exchanger. Our metal should always be able to be made shiny. If it's gotten dark, then we've overheated, we've overtempered it, we've done things we shouldn't do. So keep that in mind, that the darker you're getting inside out, if you can't get it shiny, there's an issue. And then again, same thing with this burner. It doesn't look as dark, but you can see how it's warped, it's malformed on the end here. We've got cracks in the refractory. So that's an example of things you'd want to correct and replace. So let me go to the next one here. Just yet another example. You can tell everything's gotten hot, and you can see how much scale was building up inside these tubes here. So let me go next. I think I got one more. So just a couple last items here. The startup checklist. It's mundane. People look over it all the time, but again, a path to success. If you can just be strict about completing these, then it covers all the steps you need in order to have a successful installation. That form is provided in every manual. If you don't find it or you can't see it or don't see it anywhere on the job site, please let us know. We'd like to get you one. And then I'm going to go here to, this is our, it's our sizing chart. So basically, if you need help sizing those pumps or if you need help sizing the boiler, please reach out to Hurley. We've got the charts for it. If you can give us fixture counts in the building, we can tell you how much hot water you'll use. We can tell you how many BTUs you need. We can really help you along in the design process. We just need a little bit of information from you. Fixture counts, what's the usage? Is this going to be an office building, a school? What's our inlet cold water temp? Those sorts of things. But we want to work with you. Reach out to us, let us know, and we'll get all this information put together and be able to size you a package according to your system. So Mike, that's all I had for now. I think I got it in time. Are there
Yeah,
any questions that have come in? Or?
yeah, you finished early. Yeah, I don't see anything in the chat or in the Q&A. Any questions from anybody here since we've got a little bit of time?
And I'll just say while we're here too.
Okay.
So this is, I didn't really talk about much. This is the tutor bit that they offer, right? So it's a pre-programmed PLC that they'll use CosmoGas uses to cascade their boilers. So there is an onboard cascade feature. They prefer to use the tutor bit because it's got so many more built-in functions that they can use for other things. There's expansion modules, there's a user interface, potential like Wi-Fi, remote connections, all that sort of thing. So that is available. And if we're going to do, oftentimes commercial water heaters are done standalone. You wouldn't try and cascade commercial instantaneous water heaters. But if you're going to be using something in a boiler application, now cascade becomes much more important. And so we do have options for that too. And it's a package deal that we can get.
Yeah, even hybrid systems using a domestic water heat pump
Right.
along with a water heater. This
And
is a
so,
good way to interface those two
right.
so that you get good communication along the line.
Or even
Good
mixing
idea.
valves and things like that. So they've got, like I said, expansion modules that they can enable. And so there's quite a bit they can do. That's case by case specific. So if you have questions about that, let us know. We can dive into that for you. So
Yeah, from simple to complicated, we can help with that.
mhm. Okay.
Okay,
Well,
great.
I appreciate it. Thank you guys for coming out. Mike, thank you for your help. So I'm going to turn it back over to Mike. But again, if anybody has questions, you can reach out to me, Mike, or anybody at Hurley. They'll put you in touch with the right people. And we'd like to talk to you more about CosmoGas.
Yeah, this is a new line for us, so we'd appreciate any input from any of you who attended. We really, really do appreciate your time. as we've been doing these. We're hoping to do a lot more in the future as far as different products that we had and different technical presentations that we have with Daryl and his expertise and others in our company. We can do a lot of different things. If you have any suggestions, reach out to your Hurley rep. Say, hey, we'd like something on a heat pump or something. Let us know. We can definitely arrange something. So thanks again, everyone, for your time and for your support with Hurley. And we look forward to working together. And we'll try and reach out to each of you and get some feedback on how you felt about the program. And thanks, Daryl. We appreciate your knowledge and your input here and your time as well. So hope everybody else has a great day, and we'll see you in the next one.